Hey, people. Yep, I am with you. See, I'm across the street, but I am also with you. Okay? So, this is what I look like. And you can see I made this today because this is what I was wearing today. Okay, let's get me out of there. Psh. All right. So, in your notes, you're going to write in that we're going to work through two proofs using coordinate geometry. Okay? And I'm going through these two with you just because I felt like I needed to. Okay? So let's start off with this beautiful picture that you'd probably want to jot down. Maybe pause video, get it down in your notes. Okay, I have a picture here that would be given to you. And then I have certain information. It's going to ask me to write a coordinate proof. And here is what it gave me. So my given statements are angle OEF, or triangle, sorry, is a right triangle. And then you are trying to prove that EM is equal to FM, which is also equal to OM. And I'm going to insert one other thing in there because in the given it not only tells me it is a right angle, it also tells me one other thing in the problem, and that is M is the midpoint of EF. M is the midpoint of EF is given. Okay, so in my picture, I'm going to go ahead and note that for myself, that that's given to me. And then I'm trying to prove that EM is the same as FM, which is the same as OM. So I have to somehow prove that OM is the same as those other two. Okay, so how the heck do we do it? Well, a good idea, a good way to start this proof, since we're dealing a lot with M's, and I see that I don't have an ordered pair for M, would be to get that ordered pair for M. So what is M? Well, M is the midpoint. That was given. So in my coordinate proof, remember, coordinate proof, CP, coordinate proof, it's all about using mathematics like we were in class with the coordinates to prove things. So by the midpoint formula, I can find M. So I would take my x coordinates. So I'm going to say using, now do I have room here? No. So I'll go on to another page. Coordinate proof. Starting it. By using the midpoint formula, M is going to equal, and then I'm going to take my x coordinates and add them together. So I'm going to look back. My x coordinates were 2a and 0, and I'm going to add those together. 2a plus 0, and divide them by 2. That's how I get my x coordinate. My y coordinate of the midpoint is going to be the y coordinates added together divided by 2. And that's 0 and 2b. So I have 0 plus 2b all divided by 2. Now I need to simplify that little mess. And I will end up with 2a over 2 and 2b over 2, which simplifies to just a comma b. So I'm going to say that that M is equal to a comma b. And now I'm going to actually use the, what other formula am I going to use? By using or finding the, well, let's just use it because you guys need to practice with it. By using the distance formula, we could find OM. We could find what other things? We need OM, we need FM, and we need EM. FM and we need EM. I'm going to need a lot more room than this, so I'm going to go to another page. So to get OM, distance formula, square root of my x is subtracted and squared, plus my y is subtracted and squared. And then I need the same thing for FM, and I need the same thing for EM. Okay, so I'm going to get those going. I'm going to set it up, and then just sub in values. So if I go look back at OM in the picture, OM here, I need the distance. Well, I have 0, 0, and I have my M coordinate, which we found out was A, comma, B. So I'm going to need to take my X coordinates and subtract them and square them, and take my Y coordinates and subtract them and square them. So I could do 0 minus A and 0 minus B and square both those. But you know what? I don't like working with negatives. So you know, I'm just going to switch that around and make it A minus 0. And if I do that, I'm going to switch that around. So it's that. So now when I simplify, A minus 0 is A, and A to the second power would be A to the second power. Same thing here. Plus B minus 0 is B, B squared is B squared. And that'll all be under the square root. So OM is equivalent to the distance of the square root of the quantity A squared plus B squared. And now the thing is, I want to make FM look that exact same way. So you want to set it up for yourself so that it does. So if I go to FM, now FM, I'm using M and I'm using F, and I'm going to subtract them in a way where I want to get A squared plus B squared underneath the root. So I'm going to subtract my X values, 2A and A, 2A minus A. And since I started out with 2A, I have to start out with the other coordinate of the F coordinate, which was 0, and subtract off that Y coordinate of the M, which was B. And I am hoping that I can get it to look exactly the same as that. 2A minus A is A, and then I'm left with A squared. So that looks good. Now here, I'm left with negative B. But if I square a negative B, think about it, that's negative B times negative B, which would be, that's a math joke, negative times negative, positive B squared. So I'm going to end up with B squared there. Negative actually cancels itself because I had 2 of them being multiplied. And look at that, I get the same thing. Okay, that's a good thing. So far I've shown OM is the square root of the quantity A squared plus B squared. I've shown FM is the quantity of A squared plus B squared, taking the square root of it. And now I need to get that same thing out of EM, and then I will be done. So EM, going back, EM, I have point E and I have point M. I could subtract either direction I wanted to. Let's say I start with 0 and subtract off A. Then I'm going to have to do 2B minus B. So let's try it. And you might be like, oh, I already know it simplifies to it, but you have to show it. So I have my X coordinates, 0 minus A, and I have my Y coordinates, 2B minus B. Here I'm going to get that negative A, but if I square negative A, I'm at A squared. Here I'm going to get B, and if I square B, I'll get B squared. So I end up with A squared plus B squared, the square root. So there I have all 3 the same. And so I can say EM is congruent to FM, which is congruent to OM by the distance formula. Yay! Okay, so that's the first part. Now it looks like I only have 5 minutes to show you or start out with you on this next one. So this other one that I was going to do with you, here's the new picture. Okay, so go ahead and draw out that picture. And I'm going to go pretty fast here because I'm on a time limit. I only get to do 15 minutes of recording here. Okay, so write a coordinate proof of the trapezoid mid-segment theorem. So, given statement and the prove statement. Given MN is the mid-segment of the trapezoid ORAP. And we are trying to prove that MN is parallel to OP. We're also trying to prove that MN is parallel to RA. And we're also proving that MN is half the distance of the quantity of OP plus RA. Whoa, that's a lot. Yeah. So you might have to finish this on your own, but at least I could start it. So let's see if I can start this with you. We need to prove MN is parallel to OP. Well, in order to prove that, I would need to look at the slopes of those lines. And if they're the same, then I've proven that they are parallel. But in order to get slopes, I would need ordered pairs on every single one of these. Well, that one's easy. But do I have ordered pairs on M and N? No. So I would need to use the midpoint formula to get my coordinates of M and N. So I'm going to say 2b. So I'm going to, that's my first step. So first step, using the midpoint formula, M is going to equal, and I'm going to show my work here, add the x's together, divide by 2. Add the y's together, divide by 2. Then I'm going to do the same thing for N. Boom, 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 boom. Okay, so you have your picture in front of you. The M coordinates, I would have 2b plus 0 divided by 2. And then I would have 2c plus 0 divided by 2. And then when I simplify that, this will simplify to 2b over 2, which then simplifies to b. This one, same thing, 2c over 2, which simplifies to c. So point M is b comma c. And point N, same idea, different numbers. I have my x coordinates, so I'm going to add them together, 2a plus 2d, all divided by 2. And then I have my y coordinates, 0 plus 2c divided by 2. This part's easy because it's 2c over 2, which is c. But then here, I have both of these being divided by 2. So I have 2a over 2 plus 2d over 2, which is really just a plus d. So my coordinates of N are a plus d comma c. So I'm going to write that into my picture, which is way the heck back here. Point N, what did I say that was? A plus d comma c. And M was b comma c. All right, now I need the slope of this line and the slope of that line. You can't just say, well, they're both horizontal lines, done. No, you have to use coordinate geometry. Okay, I have 1 minute left in this video. Okay, so I will show this part. Coordinate geometry. I'm gonna say I'm gonna making use of using the slope formula. Okay, using the slope formula. I want the slope of MN. How do I get it? Use the slope formula. y2 minus y1 over x2 minus x1. So I'm going to take my y coordinates and subtract them. So I'm at c minus c over my x coordinates, subtract them. My x coordinates, I had the quantity a plus d, and I need to subtract b. What do I get there when I simplify? 0 over a plus d minus b, which is just 0. Cha-ching! So now I need to get the other slopes and show